So we want to see if the given series is absolutely convergent, conditionally convergent, or divergent. So in order to do that, you will have to use the integral test. Okay? So basically what I'm saying is you're going to use from 7 to infinity, the integral limits, x squared, you're going to substitute k with x, right? X squared e to the negative x dx. Why negative x? Because e to the k in the denominator can be treated as e to the negative k multiplying without the fraction, right? So we get it this way. Okay, so notice that what you will need is this. You will need a limit as r approaches infinity, right? So that you substitute infinity with r from 7, x squared e negative x dx. First, let's find the antiderivative of this, right? So what do we get? X squared e to the negative x dx. Using integration by parts, you're going to get use x squared, du is going to be 2x dx, dv is going to be e to the negative x dx, v is going to be negative e to the negative x, right? So this is going to give us negative x squared e to the negative x minus v du, minus with that minus gives you plus 2 x e to the negative x dx, right? Using the integration by parts one more time, u is equal to x, du is equal to 1 dx, dv is equal to e negative x dx, v is equal to negative e negative x, right? So then what are we going to have? We're going to have negative x squared. Well, actually, let me work here. We're going to get negative x squared e negative x plus 2, and then what are we going to get here? Negative x e negative x minus v du, minus with that minus gives you plus e negative x dx, right? So that's going to give us negative x squared e negative x minus 2x e negative x. So the added derivative will be negative, right? Negative e to the negative x, so negative 2 e negative x plus a constant, right? So we found the antiderivative. So now we'll keep the limit here. So we're going to get negative x squared e negative x from 1 to r minus 2 limit as r approaches infinity x e negative x from 1 to r, right? Minus 2 limit r approaches infinity e negative x from 1 to r, and that's it, right? So let's keep going. So we have 3 terms here to worry about. Okay, so let's see. The first one gives us negative, let's see, r squared e negative r minus 1 squared is just 1, so it's just e to the negative 1, right? Okay, minus 2, the second term now, this limit as r approaches infinity. We have the upper one, so r e negative r minus e to the negative 1, okay? And then finally the last term, minus 2 limit as r approaches infinity, e to the negative r minus e to the negative 1. Okay, so let's see what we're going to get. So I'm going to separate this work because we're going to need some space here. So what are we going to get? We're going to get, we're going to probably use Hospitals. Yeah, we will use Hospitals. So we're going to put the negative here outside, right? We're going to put the negative there. So r squared e to the negative r, so we're going to be doing r squared e to the r, right, like this, as a fraction, eliminate the negative in the power. Right, and then we can distribute the minus, so we can do plus e to the negative 1, right? Let's work here. Minus 2, we're going to work with this one now. Minus 2 limit as r approaches infinity of r divided by e to the r again, and then we're going to distribute this minus 2 to this. It doesn't need the limit, so plus 2 e to the negative 1. Okay, now the last term, minus 2 limit as r approaches infinity, e to the negative r, right? So it's just we might as well just evaluate it, right? Because it's just e to the negative r, right? So we might as well evaluate that. So negative 2 times, so it's just e to the negative infinity is 0. That's the limit value, minus e to the negative 1. Perfect. Okay. So let's see. Using the Hospitals twice, the denominator will stay the same, because no matter how many times you take the derivative of e to the r, it will always be e to the r. This will become 2r, and then it will become 2, right? So inevitably you're talking about negative 2 over infinity, right? Negative 2 over infinity is what? Negative 2 over infinity is 0, right? So it's just 0 plus e to the negative 1. And here again, even though this is indeterminate, you will take derivative using the Hospitals rule. R will become 1, the derivative, and e to the r will become itself again, right? No matter how many times you take the derivative in the denominator, right? So it's going to be 1 over infinity, which is 0, right? So it's just going to be minus 0. I'm just writing the minus because there's a minus sign, but it doesn't matter. With the 0, you can write plus or minus, the same thing, right? Plus 2 to the e negative 1, copying this, and then minus, well, actually plus, right? 2 minuses, plus 2e to the negative 1. Perfect, right? So it looks like we will get a value, right? So we'll get 2 plus 2 plus 2, right? So we're going to get 5e to the negative 1, which is equal to 5 over e, right? So this is a convergent value. So it tells you that using the integral test, you will get a convergent value, right? So this is going to be now keep in mind, this is going to be absolutely convergent, right? Absolutely convergent. Now, why do we say that? Because if you take the absolute value of this, right, you will still get k squared over e to the k, right? Because essentially what you're doing is this, right? And it taking the absolute value produces the thing without the bars, right? So it's still absolutely convergent. So thank you so much for watching, and I'll see you in the next video.